Hello and welcome back to Vis Tutorials. Today we'll continue our high score development and we'll be addressing storing, writing and reading the files. To do that, first of all, we need to create the high score data class, which will be holding the player information data, and also it will be able to read and write these processes. So, one step at a time. I would like to try to do this lesson a bit quicker than the last one, but still not skip very important information. Creating new information, let's call it the high score data. So we know the data is related to our binary, and as you can see, it's not inside in mono behavior. So that we just need to delete mono behavior. And also it will need to delete start and update. So literally we just created a public class. Also we need to add one more specific thing on the top in the square brackets called system.serializable. Okay, of course we can delete using Unity Engine because, as I mentioned in last tutorial, we only can use variables which one is native to C#, not unique to Unity, etc. We can't use vector free, we can't use game objects, we can't use transform, etc., etc. And this only leaves us to use like floats, integers, booleans, bytes, characters, string, etc., etc. And sometimes if you want to save some data, like a vector free, the player position, then you save the game and you want to remember where this player, location of the player. So it's you always kind of work around. Vector free is actually an array of the free floats, and you just, instead of saving vector free.position, you can just save the free floats, give a name xyz, save as a float, and when you read from a hard drive, then you load your game, you just read the floats xyz and you create a new vector free position. So you always can work around all these unique Unity variables. You just need a bit, a brainstorm sometimes. Okay, for us, the high score will be a class which we store. But if you look in here, so high score will be class which one stores a player information data, but we don't know how many player high scores we need to save. Well, you can say because you decide this number at the beginning, etc., but let's make the script very flexible. Let's not assume that it's only 10 top players you want to show. Maybe you want to show top 100, maybe you want to show only top 5. So let's make it more flexible, and at the same time approaching this storing and writing data allows you to get a skill where you can actually write and deploy a different number of variables. So what I mean by this, instead of we storing, public string name, instead of doing this, let's store an array of names. Names. The problem is, we'll have a problem here. So I'll give you an example here. So int scores. Yeah. So the first problem is that storing data like this, each data is not it's not what's called connecting to each other. What I mean by this, so let's open our Trustful Paint, and each variable I draw like a square. Okay, this is a name and this is a score. This is a name and this is a score. And let's let's draw even more. This is a local, local, or any more information. Sometimes you want even more information, etc. Let's think a bigger game where you have a player and you have his equipment and his stash and all the money he has, etc., etc. So all that stuff. So storing data like this, you need to, it involves a complexity where you need to know that this variable is linked to this variable and this variable. And let's say in a high score, if you move the first one to the second place, you need to make sure that when you move this one, x is still linked to the same name and the same score. And it involves a lot of complexity because sometimes you can swap only one variable but not swap the name and did not swap your score in a high score table. So if you move something, you need to move all the variables assigned to this player. And this is where we need to nested classes. Nested classes means instead of we treat player information as separate entities, we treat the player's all information as one entity, as a class, within class. So that's what we call a nested class. So all the variables like etc, position, name, score, local, etc., will be inside in one class. And if we decide to move, this class, we'll be moving all the class, in our table high score. Another way to think, it's like grouping. So nested classes allows you to group up your variables into under one class name, and if you work with that one, you move that that whole class and all the variables inside it moves together. Okay, so to achieve that one, it's instead of we creating here what's it called, our variables, we just create another public class, and we call it a player data. And because it's outside of a mono behavior, I can use the same script to create a multiple multiple classes in the same script. So I don't need to create another script. I can just use the same script and write multiple classes on the same file. And because it's not mono behavior, I cannot attach to game object, and I can have multiple classes, etc. I hope so that makes sense. Okay, system dot serializable. Okay, we need to make sure we put this one above the class. That not to go into technical, we need to put here to allow this class to be serialized into file. Okay, so high score, our main class, will be holding a public what variable type? Variable type will be very simple, player data, and we wanna call it, I don't know, we call a scores, maybe? Yeah, scores. I think it's scores. Okay, scores. I want it to be an array, scores, and we wanted to create a new player data of 10 by default. We'll be adjusting this number each time when we read a file. We double check how many player data is in that file. So by default it's 10, but if you saved 100 player informations, it will be read and then adjust this array accordingly. Okay, so now we created if you imagine now what we've done, we created a 10 classes. Yeah. Now with 10 classes, which one could be adjusted later on. This number can be adjusted inside in that 10 classes, what we want to have inside in that class. So if we created 10 boxes, but what we exactly want to see, you know, what information each box must to have. And here we will do this. We can have a, well, we want a public, very simple, int position. So what position it takes. Then we want to public int, not score, but we need later on. Let's keep it the same sequence. So we want to so public string name, and yep. Then we want a score, and then we want a public bool local. Is it local or not? Okay. And from a previous lesson, we learn how we can actually to how do you say it? How we can modify the default constructor of a class. So by default, if I create a class, and we just saw the position, a name, score, and a bool or local. So we just create a class. We just create a class with 4 variables, and we create another class which one holds 10 of copies of this. Yeah. So this is how it looks. But by default, when we create class like this, inside we don't have anything. It's null. By default, that's how each class will be created. Well, it's not null because it's primitive, but okay, let's not get too technical here. Imagine this way: we create a class and there's nothing there. Okay. Again, more advanced, not all variables can be null because it's primitive, integer, etc. never can be null. But for sake of explanation, you create a class, it's nothing there. Okay. And to sort this one, we can actually to define that if you create the player data class, that this green box, on creation time, when you're creating it, you need to pass some variables. You need to give some variables if you want to create this green box. Yeah. And you, of course, you need to give 4 variables if you want to create. You need to give a name, sort of position. You need to give a name. You need to give a score, and you need to define as a local or not. And we can actually tell the code that this is necessary if you wanted to create this green box. To do that one, we just create a public, and this is a different. You don't need to write void. You just need to say public. Then you type the same name as class itself. And this is how the constructor is defined. By default, it's empty, and most of the times, 95% of times, when you create a class, you're not even adjusting this constructor. But this time is a bit different. We need to change the constructor. And if you're constructing a class, we want that script will request us to give a int underscore position. We want that it will pass a string of underscore name, int underscore score, and of course bool for underscore local. And when we create this class, we're receiving these 4 variables. We want to store it. So we're saying, okay, the position is equal to underscore position, name is equal underscore name, and so on, so on. So all these variables will be passed as parameters into a class, and we will store them locally. So we can access them later, okay? Okay, so, do I want to do this way? Or maybe I want to do something else. Even though I just explain this, what's it called, methodology of this, I wanted to show you, I want to showcase you overload. So you can actually create a multiple functions with the same name, but different parameters. So if I copy player data and I put like this, the system says, okay, that's an error because you have two identical functions. Well, in our case, it's construction. In our case, it's constructor, but let's treat it as a function for now. So we have two functions, and a player, well, our IDE says, well, what the hell are you doing? It's the same function. You need to give it a different name. But look what's happening if I delete one of the variables. And of course, yeah, it gives an error here. Okay. So straight away, our this script says it's no problem. You can have the same functions, the same constructors, the same functions, as long as they have a different signature, and the signature is a different parameters. So when I call this function, depending how many variables I'm passing into brackets, I will call either way this instance or this instance. So the script will know which one I'm talking about, even though the name is this name is the same, just because either way I'm passing 3 variables or I'm passing 4 variables. In this particular example, what I want to do is I want to do this. I want to have a default. I want to have a default constructor where the position will be -1. The name will be dash dash dash. The score will be 0, and the local will be true. So now I have 2 constructors. So when I create this box, I can create this green boxes in 2 ways. I can don't pass anything like this, and the default values will be filled, or I can construct a green box and I can define what's position, name, score, and is it local in the parameters. And this is perfectly allowed to do. And the same is applied to any function. If we go in I don't know, high scores here somewhere, maybe update UI, I can copy and paste, and it says, okay, update UI you can't do because it's 2 of them, but I can say this one int score. So int score, I don't know, int variable, anything. Yeah. So now when I call on a line in a line 4 to 8, it will call this instance because the bracket is empty. But if I put integer 1, straight away the line 4 to 8 now knows that I'm not talking about this. I'm talking about this because the name and the variable inside in the brackets matching this. Without brackets is this one. Viv parameter is here, and I can keep doing it. I can have another what's it called, another script where I have 2 variables, 3 variables, and so on and so on, and each of them could be unique. I can say here that I want to do it just like this, as a really quick example. Okay, so let's get back to original. Okay, score data player. Okay, I have all the score data I need for creation. Let's have a look in a high score manager, because high score manager will be actually calling this functionalities. First of all, 2 things. First of all, I need to say that I need to store the string path, and string path will be used local location where to save a file. You can always define. You can say that path is equal to C, I don't know, users, etc., and so on. Oh, okay, that's new to me. And so on, so on. But let's say in our exactly example, we have Androids, and sometimes different Android version, especially Samsung, they have one UI, a version of the Google Android. It could be, let's think even wider. Maybe making a game for a PC. It could be for Linux. It could be for Macs, or it could be even for what's it called, Windows, etc. So because of that, you need to have really great solution. It says, let me check my okay, yeah, it is application and dot persistent data path, and this is a location where the game is stored. This is a location where some files are allowed to save. Okay, it's not in if you think about the phone, it's not something where you can find in the documents or your, I don't know, photos album. It is somewhere inside an Android memory, and more precisely is Android data com dot your company name dot game, that folder, and inside you find this one. So that is application persist data path root. From here, we need to add we can just add a high score dot data, or we can actually even create some subfolder. We can actually we can say, I don't know, data storage. Okay, so this means I just create a folder in that location. I create a folder, and inside in the folder I create a high score dot data. Again, this dot can be anything. I can put dot obj. I can put code if I want. This ending of file, it's what's it called? It's not related at all. We're storing the data as a binary, zeros and ones. The file will be read as zeros and ones. What format of that file, no one cares. You can even confuse your people actually putting PNG. Someone will think it's an image, and someone will try to open. Of course, it will be not opening, but from Unity perspective or from C# perspective, because we'll be using some C#, what's called approach. From C# approach, it don't care, because it will take the file and reads as zeros and ones. If it's integer, it reads 32 bits or 8 bytes, if it makes sense. And yeah, I think 32 bits, 8 bytes, 4, yeah, I think, no, 4 times 8 bits, 42 bits. Yeah. So what I'm trying to say is, because in our binary file, oh jeez Christ, can I just do something like this? Yeah. So in our binary file, it will be a lot of zeros and ones. Yeah. 0 and 1s. And if you look in that file, you just see a lot of, garbage, etc. Unless you know the structure of your file. What I mean by structure, I know where my score integer starts and is 1, 2, 3, 4, and finish. Then I know that next 4 of them is I don't know, position integer again, 1, 2, 3, 4, and stops. And here I know that this is string, so a string is, I know where it starts and finish. If you don't know the structure of the file, you can't revert. you can start guessing and do a lot of things. You can actually spot which variables are changing every time you save something. Again, it's a hacking in the games, but it's a totally different topic. What I'm trying to say is, when we store in the binary, because C# knows our class is position, name, score, this one, int, string, int, bool, because it knows this is order. It knows the C# will know how to read this zeros and one, where to stop and start another variable, and it doesn't read the garbage. Output will be correct output. So the point I want to make is very long actually point, very simple. Any file type is acceptable. You can put anything here. I want to keep it very simple, and I want to keep it data. Also, for developing purposes on Windows especially, put debug.log and put path, so you can actually see where this file is saved in your computer. And it somewhere should be in user and app local, then low, and so on and so on. We will see in a minute actually. So we can actually run and see where this file is saved. Okay, let's have a look. Yes, see users, app data, local low, default company, gravity ball, tutorial, blah 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 blah. So this is the location where that file is stored, and you see it's a subfolder, data storage, and it's at the moment is nothing here. Okay, so, and let's delete this subfolder. I want to just drop a file here. Okay, so yeah, we can comment out the debug for now, or leave it until I find it. And we just create a high score class which one holds 10 of them. So what we need to do is to say that high score data, high score data with a lower h, this is not a class name, is equal to new high score data. Okay, and this is like I said, this is a default constructor. We just created this class without any parameters. This is you done so many times, and yeah, that this action new class followed by bracket is constructor. And as you look in this, our class, it does not have this thing, which one is public high score. We have not defined this default data. We did not define this default constructor, because by default we no need to do the script. Our IDE is assuming what's it called? It's not assuming, but it's giving you this default constructor. Okay. So we've done all this stuff. Now we need a what we want to start. I think the easiest way to start is to actually store the data. Yeah, that's great. Yeah, we don't need to update. We want to void save high score data. Okay, and we need to do some homework here before. We need to do what we need to do. What we need to do. We want to. Oh, okay. So, what we want to do. Few things. I don't know what to start actually explaining. Very simple, but like I mentioned before, this number 10 is default number of 10. When we're saving this data, we want to make sure that our high score table, which one is visible on the screen, is matching our high score data. So back to the drawings. We have a high score and we have a high score data. So let's be very clear. When I'm talking about high score, it's something what we saw on the screen. There's something what the player sees, and a high score data is what we're storing in the file. Okay, so coming back here, we want to say that high score data dot scores is equal to new player data high scores count. Yes. So we want to say that high score data, what we're storing in a file, the number of scores is what the number we can see on the screen. So let's say by default it's 10, but we actually showing 20, top 20. Yes. So that we're saying, okay, we want to store not actually we don't want it to store 10 scores. What we want to store is 20. So that's why we're saying, okay, similar like we done before, it was 10. You can recognize the scores is equal 10. Here, scores is equal 10. What we actually want to do is not 10 or something. We want to say high scores dot count. So how many we can see on the screen. Okay. Now for each for int is I is equal 0, high scores count I++. That's really good guess, actually. I like it. And what we want to do here, we want to create a new high score. So high score, it will be high score at I. Yep. So we want to take the each element. So first one, second one, third one on the screen. Yeah, we will call high score. And then what we want to do is we want to create the new, what's it called? We want to create a new green box. We want to create this green box in our binary data. To do that one, we're saying, okay, high score data. Oh no, lowercase. High score data. Oh my gosh, lower h high score data dot scores at I. Yep, and I is equal to new player data. Yeah, player data. So now, as I mentioned before, now I can do two ways. I can say, okay, high score at I is equal new player data. And that means that I just created a new green box, and that green box has, I just called this one. Yeah, you can see reference is now 1. This reference is 0. This reference has 1. And by doing this one, they do have a default values. But I don't want a default values because I know the values because we're showing this on the screen. So what I need to do, I can do two ways. I can say now, okay, this exactly high score data dot name is equal name. Then I can say score is equal score, and so on and so on. But we've done a very good job, and we can actually call another constructor, this constructor, instead of this. So we can actually construct the green box passing over variables. So, and if you start typing, it's what's it called? It's integer was position. So high score dot position, comma, and you can see now it's a pop-up small table which one says 2 of 2. I can use my arrows and I can see all the different constructors. I have this constructor which one doesn't take any parameters. I have a constructor which one takes int position, string name. Okay, so the name is really easy. High score. No, what's the problem? High score. Oh, capital S. High score dot name, comma. Now I can see it says it's, by the way, I don't know what's a recording you can see, but it will it bold the variable, which one you need to type now. If I delete the comma, it gets a string name gets bold. If I put a comma, the script knows that I wanted to go to the next one. The next one is score. So high score dot score, and the next one is a boolean is local high score dot local. So yeah, that's how we can create the green box, passing all the variables, and suddenly we create the green box with the variables already inside. Okay. Then we done this. So we done step one. Step one was step. So just to summarize, step one was we updated high score data, and before writing it to file. So very simple. We just literally we adjusted an array size to the amount of high scores we can see on the screen. Then we look from each high score on the screen, and we created a player data within another class, etc., inside the class. So high score data class, which one is here, now has the same number. Not 10 was the default, but this one was overwritten. Now this class was created, and each class inside was updated to match exactly the variables we can see on the screen. So in that case, our high score data is updated and ready to write out. To do that, we need a C# binary formatter. Binary formatter, yes. And by the typing binary formatter, it added. It did not add it. Oh, here it is. System runtime serialization formatters binary. If your Visual Studio does not adding this one by default, you need to type in on the top system.runtime.serialization.formatter.binary. Then you can use binary formatter, and we just say formatter is equal to new binary formatter. Okay. Then we need a file stream, which one we'll call FS, stands for file stream, and we're saying it's equal to new file stream. Okay, file stream. To do that, we need to pass two variables. We need to pass a path. So, okay, file stream will be opening that location or will be navigating to that location. So we can use our path because we just created at the start. So our path where we want to, write this file. And also to file stream, we need to say which mode we, addressing this file. So is it writing, or is it what's it called, or is it creation, or opening, or read, or write, etc. Well, save high score is actually create, and we just need to have file mode dot create. And why is not read? Why is not write? A different is because we don't want it to keep adding data in that file, or what's it called? Keep add something or create a copy of that. No. File mode dot create will overwrite the file. So if we have a file over there already with the previous our high score, file mode dot create will overwrite, so deletes and creates a new one. And at the same time, if it doesn't exist, it just creates. So we don't need a copies of the high scores. We always want to store the newest high score, or most updated high score in our memory. So when we load the game again, we have all the scores here. Okay. So file mode create. Okay. Then we have this formatter. and we want to serialize. We want to pass our what's it called, our file stream, and when we want to pass our class, which one is serializable. So serializable high score data. Okay. And what it does, it takes the class, takes all the variables, and serialize, puts in zeros and ones, and use the file stream, which one is located, which is looking, opening to that path, and it has already mode to create. So using this file stream and the data we're passing, formatter will serialize it and stores as a zeros and ones. Okay. One of the most important thing is don't forget to close, because this will open a file stream.
Slowly kisses passing by the river.
So this of line 48 will open file stream, and always we need to close it, because that could lead to very abnormalities. So some strange things could actually lead in your script. Okay, and this is a step 2. Using file stream to store serializable class as binary data. Okay, did I spell correctly? Yeah, was close enough. So step 2, using file stream to store serializable class as a binary data, and that's it. So we have save a high score. Okay, now we need to read. We need to read this what's it called, void read high score data. And here's a bit more a tricky part, because first of all, we need to know if that file exists in the first place. Maybe that file doesn't exist at all. So how we can read something if it's not there? So first of all, what we do is it's very easy actually. We just say if file dot exists, and we just sending the path. Okay, we do something here. If a file doesn't exist, so what we want to do, if a file doesn't exist, else we just want to save high score data. So what I'm trying to say, if a file doesn't exist, save the information we currently see on the screen. Create that file, just save it. And because we on the screen will the first time we launch a game will be zeros and empty names, we just wanted to store that one information in the memory, because next time we read it, we have zeros, and that really helps, because if someone scores a point, we have to compare to something. So yeah, if a file exists, do here. If not, save a file with default values. Okay, and there's another check here. So then we need to do reading. So binary formatter is equal to new binary formatter. Okay, so far so good. Similar like previously, we need a file stream fs is equal to new file stream. This time we're giving you path, but file mode is open. So we want to open the file instead of creating. Okay, and this is where you can actually fail. If that's why we're checking if file exists, because if we try to open it, it will be failing up. Okay, and now we're just saying okay, high score data, that class is equal to formatter formatter dot deserialize, and here we wanted to give our file string, and then we want to cast as a high score. This one we covered last lesson, so literally whatever you're reading, put in this class, okay, as this class. And yeah, that's it. Now is the other bit. So high score, we just read that file. So we checked if it exists. If it doesn't exist, okay, we create it, and this is all good. So, but what's happening is if this, you developing the game and you create 5 top scores. A few weeks later, you advance in your script and you thinking, you know what, I need to go from top 5 to top 50. And but this, every time you read your high score, it's only 5, and it will start crashing or showing you out of well, what's it called, arrays out of boundaries. And it mainly is because the file you store and you just read it is not matching what you have on a script on a screen. So what we need to do is we need to check this. So we need to say if high score data, the file we just read, dot scores dot count, scores dot length, length, is equal to high scores dot count. Okay. And yeah, one is the length because it's an array, and another one is count because it's a list. But both of them will return how many members they have in a group. So the file you just read could be only 5 high scores. On the screen, you want to show 50. So if that matching would do the magic. If it all good, all good, let's carry on. Yeah. But if it doesn't match, well, what we want to do is what we want to do. And we want to do, we can do a few things. First of all, we just can do debug. I don't think I've showed you this one before. All the time we've done log. Yeah, but what you can do also, it's a log error. So in our inspector, in our Unity editor, so where we have a console, the message will be not a white, but this will be a red one as an error, and it will have exclamation instead of this one. I don't think we have an error here now, but yeah, we can just say debug log error, and we can say that let's copy one of the so I have already written. Okay, failure to match binary data with UI. High score will be rewritten. And what we want to do is just save high score data. So what I mean is, if the data we stored is really actually not matching the new UI, what we do is we give an error because actually we made a massive change, and we just overwrite with default values, but with the new number of the what's it called, of the members in the list. So what I'm trying to say is, if you create a game, you have a top 5, and then you release a new what's it called, a new version of the game which want to show us top 50. What it will do is will overwrite the number of all the 5s, and you give new 50 by default. This problem could be addressed, and I'll leave to myself a note. So to do check to do not lose already captured data for a new new size of high score. So it will be a bit complex adjustment, because you need to find out. It could be opposite. It could be that file you saved was 50, but you decided, you know what, I wanted to do only 10 table size of 10 instead of 50. So you need to only to take the top 10 and store it. Or it could be vice versa. You need to, if you store 5, but your new table is 50, you need to take 5 of the top players, save it, and create another 45 into that file. And you need to check which one is higher, and accordingly to adjust your script. So for that, that will be in the future. At the moment, we assume that we decide that one number of a high score size, and we carry on with that one. Okay, if it's all good, what do we need to do? So, oh, by the way, very quick, why I'm using to do. It's very simple, very good technique. I learned this one in university. And when you hit Control F to find, and you have to do, you select to current project or entire solution if you want. And then you just press the next one. It will jump in any location, including your comments, where you left to do. So if you left somewhere yourself a note, once in a week, sometime before you backing up, you just go search to do, and you just loop from over to do, read your notes, because sometimes you have an idea, you left some notes, but it's really hard to pick up where you left something like this. So you just starting by saying to do allows you to know later on to find it where this note is left. Okay, and of course it could be like this, or any note. Start with a specific keyword that you can afterwards find it. Okay, so what do we want to do here? It's very simple. We want to player data. We called a player just score. Score is, oh yeah, let's make it clear. Score data is equal to high score data dot scores at I. Okay, so we wanted to I forgot 4. Yeah, as long as high scores dot count. Okay, so cut paste. Okay, so we want to loop for all the high scores on a screen. Yeah, for all the high scores on the screen. Each time we loop, we want to read one number from a file, which one is high score data scores at I. Yeah, we wanted to give a name, score data. This score data, each time we loop, will be a different member from our this one. So it will be, in the first time it will be this line, its second time will be this line, third time, and so on, in 100 times, or etc. etc. By the way, here's a arrow how it looks. Yeah, it's a red. Okay, so each time we want to loop, then each time when we're looping, we want to say that high scores on the screen, yeah, high scores at I on the screen, we have set data. We created very nice function in high scores where we have a set data, and when we set the data, we have update UI also followed inside. So what we need to do is just by calling set data, it will store the data and updates UI. So what we need here. So what we need to here, we can delete and have a look at our helper. So when we put the first bracket, straight away the small window pop-ups and says that it's a bold font. It says int position. Okay, score data dot position. Then we have name. Okay, very straightforward. Score data dot name. Okay, then we have a score. So score data dot score, and the last one is a boolean local. Score data dot local. Okay, and that's how we just read a data and we store it. Okay, now we want to read and save is straightforward. So we want to read our data when we opening our main menu. So we know the path, we just read it. If the file doesn't exist, we're creating. If file exists, we double check if it's no error. If it's no error, we read the file and we update our UI. Very straightforward. The problem is that we don't have yet how to say when we finish a game, capture the score and store it. So it's not nothing what we can actually check at the moment, but I'm thinking a way we can actually do something. Yeah. When we're creating the new high score, yeah. Okay. You know what we can do is we can actually store. No, we can. Okay, we can store. Yes. So first of all, we can actually run this one to check is no problems. So the object with ID 3 was referenced in. The object with ID 3 was referenced in the fix-up but does not exist. Serialization exception. Okay, and where it was called from, if we can see where it was called from, it was manager line 40. So that exactly should be false because this path does not exist. And save. I forgot to save. Yes, sorry, my bad. Okay, run. Same problem. And exists. Okay, let's have a look. And exists path. If file exists, do this one. But the file doesn't exist. So let's do this way. Okay. One more time. Yes. Okay. Oh, I know why. Like I said before, don't forget to file stream.close, because that could cause to various different what's it called, very interesting different abnormalities. And yeah, each time you opening something, you do your stuff and then you close it. Okay, so no need double close. So we just write a file. Now we read the file, and inside the file is nothing there. Okay, so what we can do now here is we say, okay, we can what's called manually insert a score. So high scores dot high scores at I dot not I, and let's do the fifth number. Score is equal to 100, and not score but name is equal to, I don't know, mm code. Yeah. And now we insert this scores. We insert the scores. We save the score. And then we read. Okay. So now we have MM code and it's a 100 points. Okay. It looks very simple. Okay. So we stop the game. Now we delete the save a game. We delete this information. Now, because that the fifth member was inserted manually, well, actually we should just start, we should finish the game, and then we should just check the score and insert that one. But I just deleted this lines where I saying, okay, the fifth member is MM code. I just deleted, and I left it just read the score. Now when I launch this game again, I should see the fifth member again MM code. Yes, and I've stop again and I play again because it is inside in a binary file. Okay, and 100 points. Okay, happy days so far. Now I just mentioned about exactly the point where we want to actually receive a new score. So public void new score, and the new score will be called, the new score will check, when we get something. Yeah. So it's a game over. Okay, this is a score. So a few things we need to do. First of all, we need to check if that new score is actually high enough to be showed on high score. Okay, so what that would do is for and we want the I to be not equal 0. No, sorry. I and highscores.count. Yeah, highscores.count. So we'll be looping via all the high scores we can see on the screen. So top 10, top 20. New score, of course, we need a score. Yeah. So we want to know how much score we just. Oh yeah, of course, we need to know the score. Of course, we need to know string name. So who got this one? And of course, we want to know if this was received locally or it was received from a server, etc. Also, this is cool stuff. You can, for a variable, you can give a default, a default parameter. So when I call new score, yes, oh, sorry. If I want to say score, new score, that's correct one. Yeah, and I put brackets. It says to me straight away, I need to give a score. Okay, 100. Point a name. Okay, name is AA. And now I have an option. And when I put this one comma, it says bool local equal true. So what it means is I cannot provide this information, and the local will be by default true, or I can actually specify it's true or false. So what it means is I'm just giving an option to provide local is true or not. And a reason is because 99% of your game, most of the times you'll be receiving this high scores locally. And maybe not even preparing to go advance and connect to the server. But if you do, you already coded and you left ability to actually specify that this new score is coming from a server and it's not local. Okay, that's how it goes. Of course, I can do even for a name. I can do say name is equal to brackets, and now I can just say new score 100, and that's it. I just call the function saying that score is 100, and all these variables are by default is brackets in this one, but still I'm allowed to say name, and of course I'm still allowed to say true if I want. Yeah. So, but in our case, we need a score as not optional. We need a name as not optional, and local is only one variable as optional, and by default is true. Okay, so we loop all the high scores on the screen. We can see from UI, and we say if score, which is we just received, is higher as high scores at I dot score, and we don't want it to say equal, higher or equal, because the high scores already in the table, they have priority. If you succeed to reach the same number of scores, no, you're not taking that place. You can take place below, but if it's the last place, you're just not getting in a high score table at all. You know, if you, another example, if I have a 100 points and you get 100 points, only you're allowed to be below me, not in my place. Okay, if that is true, we do magic here. Okay, and why I wanted to a bit pause here, because we need another function. So if you look in this one, oh, we need a new one now. File new. That's it. So actually, I can show you here. No. Okay, so let's assume this is our high score, and each line presents a player. Yeah, and now we have a new line. Yeah, so each time this new line takes a place, instead of this one or instead of this one, we don't want it to delete that line. We don't want it to delete this player. What we actually want to do is, if this new score is not higher than this, okay, let's go next one. If it's not higher than this, okay, let's go next one. Is higher than this, okay, that means I need to be here, but this player which place is taking here, it needs to go one line below, and that needs to go one line below, and that needs to go one line below, and so on. So when I take this place, what actually happens, that the last player will falls out of the high score, and every single player below me just scrolls down. And to achieve this one, let's create a new function, void move scores. Yeah. And what we need to do is we need to know a starting point. Yeah. So we need to know which place in a table, you know, we need to start. If this green wants to go here, I need to know that number 3, I need to move down. Okay. So a starting point. And this is could be a bit confusing. It's a starting point where we need to, you know, to move everything down. But easiest way to do is actually from a bottom. The easiest way to do is start kicking all by one down, and this will insert here. That's very easy like this. Okay. So to do that one, for instead of I is equal 0, we do a I is equal high scores dot count -1. Okay. And I is, as long as I is greater than starting point. Okay. So we start in the bottom at number 10. Yeah. But in array, yes, it's a 10 members, but the array member is 9. So when we say high score count, yes, it's 10, but we need a 9th member because it starts at 0. So you need to subtract 1 all the time. And as long as I is greater than starting point, so that means that we start looping one by one until the third, yeah, the third position. So we do 7 times. Okay, so a starting point, and instead of increasing, we need to decrease. So I minus minus. So it's not going. It's not starting at 10 and increasing 11, 12, etc. No, it starts at 9 because we subtract 1, and it will do until we, and as long as I is greater than starting point. So it's do until it's greater than 3. So the last location it moves, it will be 4th. Okay, and as long as I is greater than starting point. Okay, what we do want to do here? First of all, we need to update position. So we were saying that high score scores at I. No, we don't want to do this one. We want to say dot position is equal to I. Literally just like this. Oh, plus 1. Yeah. Again, it's a 9, but position is 10th. It's a 9 in array because it starts at 0, but our high score table starts at position 1. You know, we don't have a race where the first player is called taking place 0. It's a first place. It's not 0 place. But in array counting, I is a 0. So that's why we're adding 1, and that's why we're subtracting here 1. Okay. Then we want to say that high score at I score. Yeah, let's do score is equal to high score. Oh, high score at I minus 1 dot score. Yes. What it means is if this is a number 5 and this is number 4. So what I'm saying is number 5 is your position, your name is equal to number 4. So if I is equal 5, yeah. If I is equal 5, so the number 5, your score is equal 5 minus 1 score. So 4th, and so on. So the 10th one will be equal to 9th one, 8th one will be to 7th one, etc., etc. Okay, and what we need to do is a score when we want to do high scores at I dot name, yeah, is equal to high scores at minus 1 name, and the last one is a high scores at, sorry, wow, okay, local is equal to suggestions, no, okay, high scores I minus 1 dot local. Okay, and that moves the score. So let's go back here. So we just find that this score is higher than this, you know, score. So let's say position 3, position 5, etc., etc. So what we want to do, we want to say move scores and starting point is I, and then we want to say that high scores at I dot set data. So because we just moved all of them, we just moved this one, and this is now, you can say, empty. So we want this new green to be inserted in this position, and that's why we're saying the high score at I set data is a new one. So we're saying, okay, that is I plus 1, so it's position. Then we want to name, and then we want to score and local. Okay, all this information coming from above when we call new score. Okay, and one more most important thing is here, when this green high score finds the first highest position in the table, looping from the top, yes, we wanted to stop the loop, because if you think if this new score will be checked with the following position, our statement is a score is higher than number 4. Yes, because it's already higher than number 3. And then it loops further. Is this score is higher than number 5? Yes. Is if the score is higher than number 6, and so on and so on. And what we need to do is, if you find in this loop, if you find a position where the score is higher and the highest position on a table, what we want to do is we want to say break. And what this will do is will stop this for loop, and the code will continues here after break, or if loop finish. Yeah. So in other words, if you could loop all the scores and did not find any score which one is higher. So another thing is, in other words, the player didn't score enough to be showed on a high score. So, and the loop just exits because it will, run in our case 10 times. It could be 100, it could be 50, whatever high scores you want to show. And then the code will continue here after break or just loop finish. Okay. And what we want to do is do two things. We wanted to update high score, and we want to save high score. What I mean update a high score, because this movement of the high scores moving up and down in the setting is only done in what's it called, on the level of data itself, but not on UI. All this information we just moved and checked the high score, is this player score is good enough, etc., is only done on the data layer, but is never showed, or UI is not updated. So the additional step what we need to do is actually to update the high score, and it's really easy actually to do. Update void update high score, and it will be easy to do because what we already create the function to do this one. So for each score in high scores, so what we want to do is score dot update UI, and we don't need any variable. Okay, so again, each member in the high scores of UI will be named score, and this code will be executed. Then another member will be picked from a list, named again as a score, and executed. Another member will be picked from a list, named as a score, and again will be executed, and so on and so on. And that's here. Let's put here update high score. Okay. And now we're coming to the last bit. It's nearly the last bit. We need to create to fully complete our things, we need to create global class, a class which one exists in within our game, and is not related to which one scene we actually we created. And to do that, let's create a new script. I want to call it last game. Okay, last game will be not mono behavior, and also it will be a static class. In other words, that this script can exist only one, and you cannot even create you cannot create another instance of this class. Okay, so last game, we want to have a public static string name. By default, you you wanted to establish the variables. So you want a public static int score is equal to -1, and we wanted to say public static local, oh sorry, bool local is equal true. Okay, now yes, one more thing is when I say public static, I'm not sure about this one, but let's see when we approach this exactly. So it's a bool first time loaded is equal to true. Okay, what I'm trying to say is when we'll be loading main menu, it could be loaded first time because we're launching the game, but it will be a different code we need to execute when we go into into the main menu from a game scene, because from a game scene we want to know, okay, we score something, we need to check, but from then we're launching the game, we just came to this main menu scene and we're trying to read a global class to trying to understand what was the last score you just got it. Well, it was not. You just entered the main menu from, just launching the game. It was no game played just now. You don't need to check anything. So that's why we have this first time loaded is true. And first time loaded, it means first time loaded as the scene was loaded first time because we just launched the game. No last game was executed, so please don't check this, okay? I hope so this explains a bit. And also, each time we inspected last game, we wanted to public void reset. Yeah. Because static also, by the way. Yeah. What I'm trying to say here is if the player, let's say the player 1 played the game, he scored 1 million, and the player 2 played the game, but he exits the game in the middle without completing the game. So we don't want that when we go back to the main menu looks in the last game and it sees, oh, the last game was player 1 with million, let's put him again in a high score table. No. When we read information from a last game, or the name, the score, the local, etc., what we want to do after we read this information and we execute that information, either way we ignore it or we say congratulations, you got in a high score table, what we want to do is we consume that data, we reset the data, because we don't want it to give ability for a player to actually reinsert his score again into the table. Okay, so what we want to do is literally, I want to just copy this once and put here delete, and yeah, okay, so we just have reset now. Okay, then we've done this, we need to go back to high score manager, I think. Yeah, high score manager, and we should have a saying check void check last game, and we want to say that if if last game, you see it's a green one because it's a static. We don't need to do something like previously with any class previously we do last game class, and when we give a reference to it, last game. In this case, because it's static, you can't create like this, because an example I give you with non-static class. Let's say high score, a high score. This is a class green, and I give high score 1. That's very perfect. Then I give a high score class again, and I'll address a high score 2, and so on and so on. So I can create a multiple instance of the same class, each time giving a different name, and I can add, and each of this instance is separate in the instance of that class, which one can hold different variables inside. Last game is a class which one is a static, and it cannot be a multiple of them. It can be only one. So that's why we can address the class directly. So I can say last game. That's why it's green, and I just can say score is greater than is greater than 0. If the last game score is greater than 0, by default is, by the way, -1. What we want to say is, let's say debug.log. Yeah. And we want to say, let's copy from example. I want to say that last game info, last game name and score. Yeah, we just wanted to actually to prove to see a name and a score. We just read from a last game, okay? And when we want to do new score, yeah, we just received a new score because it's not 0, it's something higher, and we're saying the last game dot score, and the name will be last game dot name, and the last game dot local. Actually, when I'm thinking, because it's the last game, it's 100% will be local because you just played it. So it's not really making sense of this one. So let's go last game and delete this one. Save. Let's go back to high score manager, and we just delete this one. Okay, and we don't need to say true or false because by default, as I remember, it will be true. It will be local game. And after we just check the last game, what we want to do is we want to last game dot reset. So we don't want to we don't want to check the score anymore. So yes, we checked last game. Last game was 100 points. This function will check is a good score to be on table or not, and that's it. And what we now is only left to do is actually at the start we wanted to actually check last game. That's the one. Nice. Only one bit left to do, and that, if I'm not mistaken, is inside in the game manager. Yes, we do have game manager. Inside in the game manager, we have a game over condition. And inside in the game over, and the score, checking ball position. Okay, I want to comment out line 59, by the way. It's quite a lot of feeding information each update, so it's a lot. And inside in the game over, we want to say that last game dot name is equal to, I don't know, A, B, C, D, E, F, and last game dot score is equal to score, and after game is finished, we wanted to scene manager dot load scene, and this is what we need to give exactly the name of your scene name. So if you go into scenes, it is main menu. Let's copy from here. Let's go back here, paste, comma, done, and I think that's all. Let's have a test. Okay, Player. We still have local doesn't exist. Oh yeah, reset cannot be reset because it doesn't exist. Is it all thumbs up rule? Check is no stars on any your scripts. That means none of them is not saved. Hit apply. We should have still on the 5th. We have still code with 100 points. Yeah. And it's not what's called in position. What I can do is actually to go at that location and delete that.
Slowly kisses passing by the river.
Okay, so I have just deleted the file in that location, which one we're printing in our console. And I hit again, it should not have a player. Yeah, it's empty. And I'll just have a good, really quick play. So 3 points. We just got 3 points with one platform. Yeah, let's get it home. Yeah, and then we have a 3 points in the first place. Let's play again. And I have a 3 points, 2. Oh, okay, I have, I think, 8. Yeah, I can see on the scroll 8. So it should go in the first place and the 3 should move 1 below. Yeah, and you can see it moves 1 below. Yeah, you can see some UI problems as you see the 10 pushing away, the 9 pushing away again. We can stop the game here and we can play a game here, and it should read all our scores and makes the same adjustments. Yeah. Now let's play again and let's get something between 3 and 8 if I manage. Yeah, I got 4. So now I should take a second place and the 3 should go even 1 below. Yeah. So 8, 3, 8, 4, 3. Great. Let's get something more. Yeah, stop the game, play a game. Yeah, read again, play mode, and let's get something above 8 now. And it should be straightforward. Yeah. Nice, nice, nice. Okay, 14. Okay, nice. And now we have 14 in the first place and 8, 4, etc., etc. I can see because of font, this points is really varies. But most important, this points is not that important compared to this this lineup. And this is a problem where, because in our UI builder, if I can click it, would be great. Okay. Yeah, in our UI builder, 1 second, and let me double check with me. Let's position and size. Oh yeah. So we need to open first of all one of them. Open UI instance context. Okay, open in instance context. Yeah, I just open this one line. Yeah, and now I can actually adjust it. Okay, and inside in the score we have a score position and size. I made a width auto, and that's why it's keep changing. And then what we need to do is go into pixels and make it 75. Yeah, so 75. Save and exit. Can we exit somehow? Return to part. Yeah, okay, return. Oh, nice. Okay, so that's how we just change it. And if we play again, you can see that all the numbers is really line up now. All the symbols is line up also, and text start lining up together, because this now is fixed 75 pixels, not auto. And same could be achieved here. It could be more padding added, because 1 is much less space than 0, or maybe no padding needed, so you can just actually don't show these things. Actually, that's really easy to do inside an UI manager. We do have where we have a high scores and update UI, we say D5. What actually we can do, just delete this one, save, and launch this one again, and bare numbers will be showed like this, you know. So it's a lot of flexibility what to do from here. Changing fonts, changing changing the icons, a number you're showing. It very relies on your UI. It very relies on how you want to showcase this, because how much space you have on the screen, etc. Maybe you want to have a high top only 3, and you have a button where you can show a full list, a different scene where you can scroll over 1,000 players, etc. Depending the size of a server or the place you're putting. A very easy location where you can store a lot of information is a BigQuery, and Unity with Google BigQuery goes very straightforward. It is like Excel table where you can actually store a lot of information and what's it called? Store a lot of information, and you can actually always, to do something there. But it's not free. Again, I'm not have explored yet a Google, Facebook gaming high score, so you can see all your friends, etc. scores. That's a different story. I will be looking and exploring something cheap or free to use, and our next lesson will be starting addressing templates of ads on this screen, and template of ads in a gaming screen, and then we have ads as a video, giving you an extra health, and then after that one we will be addressing how we deploy the game into App Store. Okay, thanks a lot for today's being with me today, and we'll see you in the next one. Happy coding.